So here's an example where we're going to use the remainder to estimate the maximum error in the approximation for e to the x. And the polynomial, the Taylor polynomial that you're given is a second order polynomial. So we're going to define the remainder using Taylor's theorem. So let me grab. So we're going to define the remainder using Taylor's polynomial, or Taylor's theorem rather. So we're going to use Taylor's theorem to define the remainder, and R2 of x, right? So we know that n is equal to 2 because that's the highest power, so n is equal to 2, and we also know that a is equal to 0. It's centered about 0 because there's no x minus a term. So the remainder using Taylor's theorem is the third derivative of a constant evaluated at the constant, there we go, over 3 factorial. So we need to maximize this third derivative. We're going to maximize f3 and x cubed on an interval. Okay, so let's go about the business of finding the derivatives. Okay, I'm going to pause here. Okay, so we're going to find the third derivative. Let's start down from f of x equals e to the x, and the first derivative, of course, is e to the x, as is the second derivative, as is the third derivative. So this is pretty easy. So the largest that the third derivative can be on negative a half is 1/2. So we're going to look at the largest that e to the x can be on negative 1/2. And again, that's equal to 1/2. So f cubed of x is equal to e to the 1/2, which is approximately equal to 1.6487, right? So I'm going to choose m to be 2. And again, it's not unique. You could use the exact value, which would be the square root of e. And so the exact value would be the square root of e. Or you can use another approximation, just as long as it's greater than it. So the next task that remains is where is x cubed the largest? So where is x cubed the largest on the interval? Oops, keep doing that. All right. So plug in all the information, right? And x cubed is the largest on at 1/2. So let's plug in all the information. We know that m is equal to 2, n is equal to 2, a is equal to 0, and x is largest at 1/2. So R2 is got to be less than or equal to 2, which is m, times 1/2 cubed, which is the largest that x cubed can be, over 3 factorial, which is approximately equal to 4.17 times 10 to the negative 2. So therefore the max error, the maximum error in using the second order Taylor polynomial, so in using P P2 of x to approximate e to the x on negative 1/2. 1/2 is 4.17 times 10 to the negative 2. Okay, that's it for that.